So I forgot to do my homework last night, and I just woke up. I had to force myself out of bed like 2 hours earlier than I normally do, just so I can do my stoich homework. I'm just gonna go back through my streams, make sure. Okay, I was just going back through my streams to make sure like the descriptions are fine. I was just kind of like copy and pasting my descriptions, but yeah, there's no tracking because my phone is still charging. Not really still charging, it is charging right now. But yeah, so I got some chemistry homework. Yeah, so I'm doing dilution stoich again, and I guess I might as well, what's it called? Just kind of like treat this as if I'm like teaching somebody. You saw me this picture, fine. It's like I took a picture of like the test questions. Please, why is this so zoomed in? Okay, there we go. Okay, the picture's actually like fine. Alright, here we go. Yeah, I guess I'm just gonna like treat this as if I'm like teaching. Like, I don't know. It's only hit, if anything. This also means I don't have to have my desk in a way that's like taking up space. Alright, so going ahead first. Yeah, first question. So if we have, too bad we can't do like underscores. Let's do PB NO3. I'll just write it in myself. NO32 aqueous plus underscore. Actually, I might as well do 2 underscores, just give myself some space to write this. I like writing all the numbers myself because this is Creed. I can do whatever the hell I want. Yeah, just testing to make sure I'm not muted again. Yep. Anyways, KCl, potassium chloride, aqueous, plus, give myself like a decent bit of room here. Well, it's not plus, it's like this, underscore, lead chloride. Yeah, lead chloride. I need a second B to be a anything. I might actually edit this down actually. Start doing freaking math lesson, like start doing freaking chemistry lessons on my YouTube channel. Plus potassium nitrate. Yeah, aqueous. Okay, save. Well, I mean, not this color. This color is awful. I don't know why it is this color. Let's go with black. Save. How many grams of lead to chloride will be formed from 50 milliliters of 1.5 molar potassium chloride. Okay, I type that in. That is tiny. That is really tiny. So let's go like 26. There we go. There we go. You'll have to see it. Okay. Okay, so I'm starting to wake up a bit more. I guess VOD gang, be blessed with my my morning voice. Alright, so starting off, we got how many grams of, okay, let's like balance this real quick. So, okay, so if we're doing stoich, I'm gonna go ahead and balance this. 5. So we have PbNO3. Why is it this color? NO3 2 aqueous. Let's make this a little bigger, so I have a bit more space to write. Let's go 56. Why not? Way bigger. There we go. Now we're in business. Will be character terms formed. There we go. Okay. Here we go. 3. Actually, I think we can go to 7 now. There we go. Okay. Right, so first, I guess might as well just do all sorts of like YouTube recording kind of shit here. Let's like move this out of the way as well. Actually, no. We keep you here. We keep you here. Alright. Okay, so dilution stoich it's kind of like normal stoichiometry, except instead of using some kind of dilution stoich is just like normal stoich, but instead of using 22.4 liters over 1 at STP, or PV equals nRT. I think it's just like lowercase r, yeah. I don't remember. Yeah, instead of using either one of these, ideal gas or 22.4 at standard temperature and pressure, we use the molarity of a given thing. So for example, the KCl is 1.5 molar. We can use that to convert it from moles. No, wait, yeah, from liters to moles. Yeah. We can use the molarity to convert it from milliliters to moles, from liters to moles, and that gets our stuff. Right. So just to balance this here, I also just need to like have this accurate. Let me grab my. Here we go. So PbNO3 2 aqueous. Let's do this a little better. AQ. That's KCl AQ. Cl2 AQ. Ooh, solid actually. And then KNO3 aqueous. So to balance this, K P NO3 PbNO3. Yeah, this is balanced. Yeah. Wait. There's 2 chloride on this side. There's 2. Okay. I forgot to put the underscore here on the KNO3. So if I could just do this. There we go. Save. Okay. Yeah, there we go. It's gonna take me forever to like actually finish this. Okay, 2. I think it's just 2 everything? No, that doesn't make sense. There we go. So let's get rid of this first. Did I write this one? KNO3 led to. Oh, wait. Yeah. So the nitrate here is 3. So 2 chloride to these, and we're good. Okay. So for the first question here, it's pretty simple. Yeah. I sound like a math channel. Yeah, so for the first problem here, how many grams of lead 2 chloride will be formed from 50 milliliters of 1.5 molar potassium chloride? So I have this equation balanced out here, and the first thing we want to do is take our given and start with that. So 50 milliliters of potassium chloride over 1. Then multiply this. So we want to get lead chloride, not like, yes, we do want to get lead chloride actually. We want potassium chloride into lead chloride. So the way we would generally want to do that is, as always, you want to convert from whatever this is into moles, and then convert that moles back into whatever unit you need. Underscore. Yeah, so to go from milliliters to moles, what we're going to do first is divide this by 1,000. You can do this up mentally. You don't really have to have this thing. You could just have like 0.05 or whatever. I don't remember what it is. Of KCl. And then liters of KCl times. All right, and then what we do here, because we can't use 22.4 and we can't use PVNRT, I mean, it's not gonna ask. We do is we use the molarity, and because its molarity is 1.5 molar, molar is the moles of solutes. Oop. The moles of the stuff in it. Yeah, moles of the stuff you put in over how much solution there is. Solution. Yeah, so hold on, let me get rid of that 1.5 just for posterity's sake. Posterity's sake, what a funny word. I sound smart, don't I? Yeah, so molarity is, yeah, so molarity equals how much stuff you're putting in over the total stuff. So the stuff we're putting in is 1.5 molar. And it's always 1 liter of the stuff. So our moles of solute is 1.5. In that case, we have 1.5 moles of potassium chloride over 1 liter, because we're using this as a conversion factor. It's very, very easy. It's like multiply by the molarity. So just kind of like show what I'm doing, because like I'm not sure if this is like standardized. On the top and the bottom, when we multiply, we end up canceling out the milliliters. We end up canceling out the liters. So now we're left with moles. Now we can do the mole ratio. There's 2 moles of potassium chloride to lead chloride, 1 mole. So just moles of lead chloride. So the reason why I kind of like leave out the 1, if there's like 1 mole of lead chloride or 1 mole of KCl, it really does not matter. I just prefer not to write it. Just for a little bit of shorthand, so when I cancel everything out, it's literally just the label. It's literally just the label. Yeah, so okay, we're at moles now, so we want grams of lead chloride. So cross out the moles. We're now in moles of lead chloride. So now we use the molar mass. So 1 mole of lead chloride would be bro, where's my brain is like really off right now. I'm not able to read chat. But yeah, I just woke up. Hello, welcome to stream. Yeah, periodic table. Anyways, so lead on the periodic table. I don't memorize this stuff. Where is lead? It's like bottom middle of the right side. Where are you, lead? Actually, straight up don't see it. I'm blind. There it is. 207.20. Yeah, so for the molar mass, it's 207.2 plus 35.5. I'm going to round it up. And I'm going to grab my calculator for this one, because I am lazy. Yeah, enjoy morning voice me while you can. 207.2 plus 35.5. Our molar mass of lead chloride is now 242.7 grams of lead chloride, and this will give us our final answer in grams of lead chloride, as seen up here. Grams of lead chloride. So if you just punch this into a calculator, 50 divided by 100, 1000 times 1.5 times divided by 2 times 242.7, you get 9.1. So 9.1 grams, going to 2 sig figs because our given is in 2 sig figs. And yeah, so it's going to be the answer for the first one. Alright, hope I can like edit that down into something coherent. But yes, I'm going to real quick just kind of like copy that down into my notebook. So it's like 50 milliliters over 1,000. Yeah, I'm not really aiming to be very entertaining here. I just kind of want to do I just kind of need to do my chem homework. So I'm going to be mumbling to myself. I'm going to be quiet. Moles. Meters. KBCl. 2 KCl times 2 for 2.7 grams. 9.1 grams of lead chloride. Right, so for question number 2, go ahead and hide these just for cleanliness. Let's get ourselves another text box. 56. Do we need yeah, 56, there we go. Okay, number 2. So for question number 2, just ramp up the difficulty just a little bit. Right, so we have to write an equation for the reaction between nickel to, typo. I'm gonna leave my paper on the side here because I don't need it for now. Chloride, nickel 2 chloride, and sodium hydroxide. Let's see how big that is real quick. Okay, let's make the line line. Okay, hit there. Okay. Now, how many milliliters of 0.2 molar? Sig figs are important here. 0.2 molar sodium hydroxide are needed to react completely with 18 milliliters of 0.500 nickel 2 chloride. Okay, let's put the return here. Why not? Okay, there we go. Right, so now switching over to pen. Be also fair warning, I cannot see chat for my life. Right, that space is killing me. There we go. Yeah, I cannot see chat from here. Anyways, so for number 2, it's the same as number 1, but we actually have to write the equation ourselves. So just kind of like explaining how I would do this. So we start out with nickel chloride and sodium hydroxide. So I'm just gonna do it right here. Nickel, 2 chloride, Cl2. Because this has a charge of 2, you would have 2 chloride ions, anions. I think I'm saying that right. And I'm fairly certain this is like, is this aqueous? I don't remember. I have a solubility rule right here. Okay. Where are you? There it is. Alright. Okay, let's like, I'm gonna re-record that entire section. I'm gonna act as if I'm like recording a video here as well, too. But yeah, so the first thing we have to do here, it's fairly similar to the first one, except we have to write the equation ourselves. So, the first thing we have to do is just write an equation for the reaction between nickel chloride and sodium hydroxide. Nickel 2 chloride. So the first thing we do here, boom boom. Oop, actually, hold on. I forgot to go right here. There it is. No tracking phone charging. Okay, I'm gonna go check something real quick. Like it's the morning. I'm gonna mute and be right back. Yeah, I've got to speed this up a little bit. I've got to do this by like 7 or something. Well, by like 8, by the latest. All right, click. All right, let's minimize some of these windows. All right, here we go. Okay, so we start with nickel 2, lead 2, chloride. Because of its charge, we bring it over here. We now have chloride 2. When it comes to chloride, most halogen salts are soluble except for in lead, so this is a solid. Plus sodium hydroxide, so it's just NaOH. I don't think any of this crisscrosses. I don't think we have any charge popping up anywhere. Click, get out of the way. Here we go. And I think this is just aqueous. Both of these kind of play nice with each other, with everything actually. Oh, most hydroxides are mostly insoluble except in sodium actually. So it doesn't play nice with most things, it just plays nice with this because it's, I don't know. Then this goes to NaCl, good old friendly NaCl, plus PbOH. Fairly certain hydroxide has a charge of 2. And it is in fact insoluble with what's it called? Insoluble with whatever the thing. So solid. I'm just gonna double check this over here just in case. PbCl, chloride. Yep. Lead 2 is in the exceptions. Okay. Yeah, so this is the thing. Oh, it's nickel chloride. Okay, not lead. I don't know why I thought it was lead. Morning. I just woke up. Alright. So I get rid of this. Okay. This is still 2. Okay, so nickel. What is nickel? I mean, I know what nickel is. It's just like, so it's Ni 58. Yeah, so, and so nickel here. Okay, that's better. Right, chloride. It is soluble with this, so this is actually aqueous. Then hydroxide is not soluble in nickel. Right, so just balance this out. We have 2 hydroxides. We want 2 over here and 2 over here, and this balances. Okay. And now, how many milliliters of 0.2 molar sodium hydroxide are needed to react completely with 18 milliliters of 0.5 nickel chloride? Okay. So we start with our milliliters. 18 milliliters of nickel chloride. Go milliliters. Liters. And its molarity is 0.5. Oop. So there's 0.5 moles of it. Null. Mole of of nickel chloride over liters. And then okay, moles, yeah. Okay, now we go to mole ratio. There's 1 mole of nickel and sodium hydroxide. It's 1:1. So it's just, yeah, it's 1:1. So nickel chloride. Because it's 1:1, we don't really have to worry about this. It's just the labels that we're worrying about. Let's use sodium hydroxide. Oh, no. There's 2 moles of NaOH. Here we go. and then it wants it in milliliters, so we just use, so instead of using the molar mass, what we want to do here, because it's milliliters, we also use the molarity of sodium hydroxide. So the molarity is it's moles over liters. So like our molarity is 0.2, and we would have 1 liter of it. When it comes to conversion factors, you're able to like sort of like flip them over, because like the top is equal to the bottom, and like 1 over 1 is just equal to 1 over 1 anyways, because like if they have the same identity, identity property, whatever. Yeah, so that gets you in liters. At the very end, you're gonna go from liters to milliliters. So it kind of does seem a little redundant, like going from what's it called? Here we go, milliliters, going from milliliters to liters, and then back from liters to milliliters at the end. But the reason why we need to do this is because the molarity is in liters. I can do this better. Go ahead and erase this. 1,000 milliliters. It's one wonky m. Yeah. So we have 18 divided by 1,000 times 0.5 times 2 divided by 0.2 times 1,000. And we end up with 90 milliliters, exactly 90. And because we have 3 sig figs as our givens, and in our molarities, we want to have a 0.0 just out of those 3 little places. Milliliters of sodium hydroxide. All right. Yeah. Time to write this down. It's a point. It gets 18. I'm not even gonna bother to write the labels. I mean, I'll write labels every now and then. 0.5 NiCl 2.2 times 1,000. 90 milliliters of NaOH. There we go. Put this back on the side. Alright. Now let's go ahead and hide this. Go ahead and do problem 3. Yeah, text layer. Okay. 56. Okay. What is the polarity of 30 milliliters of HCl if this volume completely reacts with 9.15 grams of calcium hydroxide? Okay. Here we go. Let's put the line break right here. Save. Okay. All right. And now for the third question. What is the molarity of What is the molarity of 30 milliliters of hydrogen chloride if this volume completely reacts with 9.15 grams of calcium hydroxide? So first off, it doesn't tell us we need to write the equation, but we need to write the equation. So hydrogen chloride, let's give myself a bigger line weight actually. HCl, about 30 milliliters of it. Actually, I don't need that here. So HCl, fairly certain this is aqueous. I don't think that matters. Plus grams of calcium hydroxide. Yeah, so CaOH. I think calcium has, I think, a 2. Yep, charge of 2. CaOH2 turns into, okay, so these are both on the reactant side, so we can just do a double swap for the double replacement for the product. So CaCl2 plus HOH2, or in our case, simply just water. Okay. So to balance this out, we have two OHs. I think we need two of these. Okay, so yeah, so no. Yes, this is just HOH, so there's one hydroxide in there. So one and one. We need two of these. Two of these. I think we need two of these. Wait. Okay. So this it. Okay. Hydrogen hydroxide really is just water, but just to visualize things a little better. HOH. Okay. So first off, we need two of these. Right? No. We need two of these. Actually, huh? 1, 2. 1, 2. Okay, it's the chloride we need to focus on. So two of these. Wait, no. I'm bad. Let's do 2. So now we have 4 on each side. We go 2 of these. And that's balanced. Okay, so I was doing it right. So we can go ahead and replace this back with water just so it looks pretty. Alright. So now that we have our equation, we can go from what is the molarity of hydrogen chloride. So what I'm going to do first is just kind of like poke and feel my way through this because I have no clue what I'm doing. 9.15, so I'm going to start doing stoich. Calcium hydroxide. Is it moles? Grams. CaOH2. Ooh, it's like bumped my mouse changing my pen. Alright. 9.15 grams of calcium hydroxide. We're going to have its molar mass down here. And we're going to have moles on top. Yeah, so we're just going to convert this to moles, and then that will allow us to find our molarity. So we want to find moles of hydrogen chloride. So, right. So, calcium hydroxide. Yeah, so calcium hydroxide. Calcium is 40, oxygen is 16, and hydrogen is 2. So it's 40 plus, it's really 15.999, but I don't care. Just round it up to 16 plus 1 plus 1. That's 40 plus 18, and that's 58. So 58 grams to moles. Let's move this over. Ooh, unlucky. Yeah, so moles calcium hydroxide. And then we go from mole, okay, so now we go mole ratio. So moles of calcium hydroxide, just 1. And we turn this into hydrogen chloride. There's 2 moles of it. Of HCl. And now we want to, okay, so now that we have like the moles of hydrogen chloride, okay, let's work with that for now. So it's 9.15. Oop. Okay, in a bit of a, I feel like I panicked a little too much there, but like I turned off my mic physically instead of just sliding down the mute. Yeah, so nothing awful happened. To saying good morning to my grandma. Right, here we go. Right, so we have moles. Did I calculate this out yet? No, I did not. So 9.15 divided by 58 times 2, 0.315. Let's get that. 0.316. Okay, 0.316 moles of HCl. So we have our moles. So now we have moles and okay, we have moles. So okay, so given our moles, our molarity of over 1 liter, 316. So our molarity here is just 0.316. Your molarity happens to be the exact same as your moles, from what I've seen. So now we just take 30 milliliters of hydrogen chloride. I don't know why I put of. Let's like move this over real quick. Okay. So we go 1,000 milliliters. So liters. And 1 liter over 0.316. Yeah, so 0.316 moles. Right? What is the molarity? Do I even need to do this? I don't think I even need to do this. Yeah, I'm just gonna do this for the sake of it. Times 0.316, and that gives us 0.00948. Okay. Okay, so like this is where like I stop being completely certain. So like I have no clue if it's this or this. Actually, I feel like it might actually be this, because I had to sort of like convert the 30 milliliters, because like 0.316 is the molarity of 1 liter, and like this should be the molarity of 30 milliliters. So going ahead and writing that down. 3. So 9.15, 5, 2, and 30 milliliters. So 1,000 times 0.316, 0.00948 molarity. There we go. That should be how you do it. Alright, question number 4. There's 6 questions in total, by the way. 58, 56. Schmal. There we go. Put my notebook behind me. Alright, number 4. 23.5 liters of 2.5 molar sodium chloride solution is mixed with a 18 liter, that's not 18, with 18 liters. What did I say? 18 liters. That's weird. With 18 liters of 1.2 molar lead. Lead to nitrate solution. Dude, I'm gonna give up on like editing this down into like a educational video. How many grams of lead to chloride will be reduced? Okay, I think that's good. Here we go. Okay. So we have a mixture here. NaCl plus PbNO3 2 turns into PbCl2 plus NaNO3. If I remember correctly, I'm fairly certain nitrate, does nitrate have a charge of 2? Just looking through my thing for, what the hell? Just doing some rifling through papers here. There it is. Nitrate does have a charge of 1, this thing. Okay. Yes, for this equation, let's go ahead and balance this. So, seeing first off, we need 2 nitrates, 2 of these, and we're good. Okay. All right. So we start with 23.5 whole liters of sodium chloride, which is super nice. 2.5 molar of the liters. It's mixed with 1.2. Okay. Okay. Wait. Yes, we're given both values, so we kind of need to deal with the limiting reactant here. Super stupid. Okay, so let's sort of do these a little parallel. 18 liters PB. I was gonna say lead. All I need. 1.32. Okay, there you go. Times 1.2. Yes, we have to use the limiting reactant. Moles. And then moles of NaCl. Not NaCl. NO32. Okay, so lead, I forget what lead is. 207.2. 207.2 plus 14, I believe. Yeah, 207.2. Oh. Oh, there's 2 of them though. Plus 16 times 6. Man. Weird way of writing it, but you know, 16 times 6 plus 28 plus 207.2, 331.2. And then NaCl, I think it's just like, I forget. 22.9 plus 35.5. 58.4. So grams of PB. Actually, I'll just treat that as given. And now, yeah, so we figure out which is the limiting reactant and then do stoich with that one. So we go grams. Okay. How do we? Okay. gonna just, whoa. Okay. NaCl. I actually kind of forget how I'm supposed to do limiting reactant. Maybe we actually do that. Just make it easier for me to look at. Okay. Now we're in grams of both. Do we need to be in grams of both? I don't think so. Let's like switch these out. If they're already in moles, we can just do mole mass. Mole ratio, right? We're going into how many lead? Okay, lead chloride. PbCl2. Moles of PbCl2 on top. I don't think any of these are actually NaCl's 2. Moles of NaCl. And then moles of that. So liters cancel out. Moles cancel out. So now we're in moles of both. And then for like chloride, 2-chloride is cell treated as 71. 207.2 plus 71. 278.2. 217.1 grams over moles. Okay, so let's go ahead and do these. So 23.5 times 2.5 divided by 2 times 278.1. So 8169. Will not care about the decimal. And then for the second one, it's just 18 times 1.2 times 278.1 gives us 6006. So our limiting reactant 6006. Our limiting reactant is this. So now we can move forward with that stoich. So just 18 liters, 1.2 moles of lead chloride. This is really all the only thing we need. So we have moles of that. How many grams of lead 2? Wait a second. Is this not literally just limiting reactant? This. It's just this. Okay, that's so easy. Right? Okay, just 6,006 grams. Alright, I'm gonna go ahead and get that down real quick. So 4, 23.5. 5 moles over liters. Two 78.1. It wants it in 3 sig figs, so I think 6006 is fine. I mean, it's in 4 sig figs, so just 6,000? 6. I think it's like 6.00 times 10 to the third. Grams of PbCl2. There we go. All right, now for number 5. Consider the following combustion reaction. I have time for this as well. Consider the following reaction. I'm just going to write it down. What is the volume of, let's also put this at 56, CO2 gas produced at 298 Kelvin and pressure of 1.4 atmospheres if you had 0.094 liters of a 2.5 molar solution of CH3OH. So yeah. Okay. So it's CH3OH. I actually have straight up no idea what that 3 is doing, because the coefficients are usually the front, so I guess I'm gonna treat that as like a this. Oh, let's just check to make sure. CH3OH. Okay, yeah, it is a subscript. That's really weird, because like there are subscripts on this paper. It's just like I guess my teacher forgot. I don't need this underscore here. Plus O2 turns into H2O plus CO2. Okay. So we have 4 hydrogens here. Yeah, we have 4 hydrogens here. We have 1 carbon, and we have 1, 2, okay, 1, 2, 3, 4. So I guess we would just double this just so we can get that oxygen to be an even number. So we have 2 of these, and 4 times 2 is 8. So we need 4 hydrogens. 4 water. So 1, 2, 3, 4, 5, 6, 7, 8. We have 1, 2, 3, 4 on this side. 4, 8. So 1, 2, 3, 4, 8. So we need 3 of these. Okay. Now that's balanced. Clicky click. Yep. Alright, let's go put behind me just so I can work. Okay. So here, what is the volume of CO2 gas? Okay, so because it's giving us all these different numbers, atmospheres, liters, temperature, like pressure and temperature is very, very important. But just kind of seeing that is a dead giveaway that it's PV and RT. So we need to find the moles first before we can find the volume. So we need to start with 0.094 liters of CH3OH, and it's molar. It's 2.5 molar liters, 2.5 moles. And go from moles of this thing, CH thingy, into, okay, yeah, so there's 2 to that, and then 2 CO2. So we don't really do too much, we just do 0.094 times 2.5. Okay, yeah. So we get 0.235 moles of CO2. So now we can take PV and RT. So our pressure is 1.4. Let's go for a slightly bigger brush size. Our pressure is 1.4 atmospheres. Our volume is going to be in liters. So I can really just drop the parentheses because there's a variable on the side. Our N, or number, which in moles, 2.35 moles. R is a constant of 0.0821, and then our temperature is already in kelvins at 298. Okay, 0.235 times 0.0821 times 298 is 5.75. Rounded to the hundredths equals 1.4. And we just divide both sides by 1.4. We get 4.11 liters. Nice. So just noting this down in my workbook, just so I get the credits for this. 2H, 3OH plus 3O2. Let's do 4H2O. 2 carbon dioxide. Give myself a little more space down at the bottom. 0.094 liters of thing. 2.5 moles. Equals 0.235 CO2 moles. 1.4 V equals 0.235. 0.0821, 298. V equals 4.11 liters of CO2 gas. Okay. And now for number 6. Yeah. Alright, last one. Okay. Put him behind me. 50 milliliters of 4 molar cobalt 2 chloride reacts with 9 milliliters of nitrogen gas stored at 745 milliliters of mercury and 25 C. What is the volume of gas produced? The reaction takes place at STP, thank God. All right. Okay, I think that's good. There we go. That is awful. Some weird AC ad on Spotify. Okay, so this is just number 4 with extra steps. So when it comes to millimeters of this is pressure. Its conversion factor is 7/760. So 745 divided by 760. We are at 58.98 atmospheres. So what we need to do here, I'm gonna go grab a tissue real quick. I'm out of tissues. I do have a packet of tissues in my bag. What? Okay. Hello, good morning, welcome to stream. Yeah. Okay, I'm back. I blew my nose. Alright, periodic table, here we go. Alright, so this is a little annoying because we have to do ideal. Not ideal, what's it called? So we do ideal. But we also have to do the limiting reactant, which is annoying. So first we gotta do the equation. This is just long, busy work. Alright, yeah, so cobalt 2. I think like CO. Yeah, CO. It's a charge of 2, as always. COCl2 plus N2. Oh, this is like a really easy equation, so NCl, I think. Right? No. It's CON plus Cl. I don't think, yeah, chlorine is a gas. Okay, there we go. So 2, 2, 2. This is all balanced out. Don't need to worry. Okay, so the molar mass of cobalt, just for future sake, 58.9. CO, and then chlorine is 35. Just for me in the future. Alright. So we go 15 milliliters, 9 milliliters. Well, it's like right, it's a little smaller. Actually, we're just a little lower. $1,000. And then, yes, 1,000 milliliters, liters. This top row is cobalt chloride. And this bottom row is N2. Give me no run out of space if I write this big. Control B. Okay. Like so liters, do we know the molarity of each? No, we don't. Alright. So the cobalt is 0.4 molar. So over 1 liter, you do 4 moles. And then, since it's STP, it's 22.4 liters, 22.4. Now we're at moles, and now moles to grams. Wait, I gotta convert. So COCl2, N2, moles of N2. It's all 1-to-1. So I don't care. We're converting this into, what is the volume of gas produced? Okay, so we're converting to the Cl2. because it's the only gas. Wait, we need to do this at the very end, so this is not it. Do we know the... We don't know the molarity. How do we get this without the molarity? Moles. We are at SCP. Like it gets us it's 22.4 liters over something actually. Let me Google this real quick. .4 liters for 1 mole. Okay. So we do it the other way around. 22.4 liters and 1 mole. Now we're moles, and then we go moles of, not equals. What am I doing? Here we go. Moles of N2. Then we multiply both by chlorine. So moles. Wait a sec. What is the volume? Okay. So this is where we do STP. Again. So 22. Wait a sec. It's 22.4 moles in 2 liters. And then we just do 22.4 moles in 2 liters. Okay, there we go. Okay, so I really don't think it's a contest as to who is the limiting reactant, because this is being divided by 22.4 twice. So we're just gonna go with that. So 9 times 1,000 divided by, 9 divided by 1,000 divided by 22.4 divided by 22.4. It's really small. Math, 2 decimal. Okay. Well, let me like mess with my calculator real quick. If I float it to 3. Oh, that doesn't help. Well, I don't know. Okay, so it was like 1.794 times 10 to the -5th. So it's like 0.0. Wait, 1, 2, 3, 4, 5. 1, 2, 3, 4. 2, 3, 4. 1, 7, 9, 4. Okay, so now we have that, but we don't need that. We just need 9 divided by 1,000 to get the moles here. Divided by 22.4 gives us 4.017 times 10 to the -4th. So 1, 2, 3, 4. Okay, 0.0004. I'm just gonna go with that. And now we have our moles. Okay, so our pressure is 0.98. And now we have our moles, which is 0.0004, 0.0821 times 273.15 plus 25 is 298.15. Okay. 0.029, 8.15 times 0.0821 times 0.0004 divided by 0.98, and we get some incredibly stupid ass number, 0.00999167. This probably goes on. Yes, so we can cut it off to 9.91. Yeah, times 10 to the negative third. Okay, and that's number 6. Okay, close my calculator, write this down in my notebook, end stream, and go eat some breakfast. Okay, so 50 milliliters. Oh, why am I reading another question? Into loading reactant. Okay. And then we go COCl2 plus N2 turns into CON2 plus Cl2 over 1000, 22.4 moles of Cl2, 0.0004, 0.98 times V, 0.0004, 0.0821, 0.298, not 0.298, 28.15. V equals 9.91 times 10 to the negative third, and I'm out of here, dude. That's a whole lot of arcane text. It's a whole lot of easy, busy work garbage, and I had to spend like a billion hours on this. Sorry that, but though I'm actually done. I'm not gonna do any proper sort of endings. I'm just gonna leave. Yeah, so. Sorry if I missed any chats. I was not paying attention. I did not have chat open this whole time. And I'm just gonna get out of here. I'm not gonna